Well, here we are back at the Cave of Science. We're looking at the gas laws practice sheet, skill practice 35. And I guess we're not going to worry about number 1 there. So let's go down to number 2. And all these, every one of these on this particular sheet are using the combined gas law formula. So P1 V1 over T1 equals P2 V2 over T2. So every one of these problems are using that. So let's look at problem number 1. We got a gas has an initial volume of 2.75 liters at a temperature of 285 Kelvin. That the temperature changes to 380 Kelvin. What's the new volume of the gas if the pressure is unchanged? So now what I might suggest that you start doing a table on these. So P1 V1 T1 and then P2 V2 T2. If you don't need to do it, that's fine, but keep this in the back of your mind. It might help you to see some of these a little bit easier. Alright, so we got an initial volume of 2.75 liters. Excuse me. And a temperature of 285 K. Now remember, your temperature always needs to be in Kelvin for all the gas laws. If the temperature changes to 380 K, what is the new volume? So we don't know what that is. If the pressure is unchanged. Well, if the pressure is unchanged, we really don't even need that into the formula. So the pressure is going to be the same on both. So we can go to this formula and not even worry about pressure. So V1 is 2.75. Temperature 1 is 285. And we're looking for V2. And temperature 2 is 380. So if we do the math, let's cross multiply and divide. So V2 times 285 and then 2.75 times 380. So we got V2 times 285 and then 2.75 times 380. 2.75 times 380 equals 1045. And so therefore V2 is going to equal 1045 divided by 285. And that's going to equal, and we need to look at the number of sig figs here. So we have 3, 3, and 2. So our answer can only have 2. So we're going to round this up to 3.7, and it's going to be in liters. So it's 3.7 liters. Again, volume is in liters on there. So that is number 2. So let's look at number 3. And let me flip this around a little bit. And so we'll look at number 3 here. And it says a gas can often be compressed by keeping it at the pressure constant. If we have 45 liters of gas at room temperature, 22 C, and I compress it so the final volume is 0.5 liters, what is the final temperature if the pressure is constant? Well, again, we know P1 V1 all over T1 equals P2 V2 over T2. And again, I'm gonna write it out here. I know it's a little long, but get into the good habit here. V2 T2. So let's see. Let's see if we have 45 liters of gas at room temperature. So we know the volume is 45.0. Now this is 22 C, so we know we got to change that to Kelvin. So Kelvin equals Celsius plus 273. So we can go ahead and see what that equals. And we know this is 22, and I think I can do that 22 plus 273 is 295. So we know temperature 1 is 295. I compress it so the final volume is 0.50. I forgot to put my decimal there. And we want to know what the final temperature if pressure is constant. So we don't have to worry about pressure again here. So we can go ahead and plug in 45.0 all over 295 equals V2 V2 is 0.50 all over T2. So again, it's the whole idea of cross multiply and then divide. So T2, and let's go ahead and do this. 295 times 0.5 equals, and then divide by 45, that equals like 3.27. We've got, it's like 1, 2, 3, and 2 sig figs there. So we'll round that up to 3.3, and that's going to be Kelvin. So that's number 3. Let's go on down to number 4. And flip this around. We got a volume of gas is 2.5 liters when the pressure is at standard pressure. What is the volume of gas if the pressure decreases and the temperature remains unchanged? Alright, so again, standard formula, P1 V1 over T1 equals P2 V2 over T2. And again, let's write it out. I know it's a little redundant, but if it helps you see it, go ahead and do it. So we got a volume of gas at 2.5 liters. So it's 2.5. When the pressure is standard pressure at 101.325 kilopascals, what is the volume of gas? So we don't know that. The pressure decreases to 85 and the temperature remains unchanged. So temperature is really not going to enter into this one. So we got P1 is 101.325, V1 is 2.5, and P2 is 85, and V2 we don't know. So pretty straightforward math here. This times this, divide by that. So let's go ahead and do that one out. So if you end up doing the math, we got V2, and we can only have, looks like 1, 2, 1, 2, only 2 significant figures. So V2 is going to be 3.0 liters. So that will be number 4. Let's see if we can do one more on this one, and then we're going to have to flip it over for the next one. So let's look at number 5. Got a 5-liter container of gas, experiences a temperature change, so the final temperature is 4 times the initial. What's the size of the container after temperature change? Assume constant pressure. So P1 V1 over T1 equals P2 V2 over T2. And so P1 V1 T1, P2 V2 over and T2. Alright, we've got 5 liters, so it's 5, well actually 5.0. The final temperature is 4 times the initial. Well, we can use any temperature. Wow, let's just call it 1 Kelvin. Why not? Makes it easy. And we know the final is 4 times. And we assume constant pressure, so that's going to knock pressure right out. And we want to know the size of the container. So we don't know that. So we're going to assume constant pressure. If we're heating it up, we would probably assume that the container is going to probably have to increase. So we got V1 is 5.0 all over T1, or we're just going to call it, we're going to call it 1. And we have V2, we don't know. And we're going to call this 4. So this one's pretty straightforward. V2 equals 20. And we can only use one significant figure. And sure enough, yeah, that'll work just fine. And again, this is going to be liters. So we're going to call this one good here, and then we're going to pick up 6, 7, 8, 9 on the next video.